Gorilla Glass is a type of reinforced glass made by Corning that is lightweight, thin, and resistant to damage, and was originally commissioned by Steve Jobs for the production of the iPhone. Gorilla Glass is used today in many technological products like TVs, computers, and smartphones, so its use is incredibly widespread.
Once the aluminosilicate glass composite is created, it is fed into a trough and melted. The molten glass then overflows the trough on both sides and rejoins to form a flat sheet. On a computer or smartphone, the purity of the glass must be maximized, meaning the presence of particles that will obscure the clarity of the glass should be minimized. Corning's glass drawing technique provides the incredible optic purity required of their product. Mainly, the pouring of the glass out of the trough allows for the drawing of very thin glass. Then the use of mechanical handling rather than handling from human hands maintains this surface purity.
After cooling, machinery cuts the glass and soaks the glass in a hot bath of molten salt at approximately 400 degrees Celsius. In this salt bath, large potassium ions displace smaller sodium ions. These larger potassium ions occupy more space and compress the glass as it cools. According to Corning's website, this compression causes the glass to become more resistant to damage. Though Corning is making efforts to maximize their glass's durability, the fact that many iPhone users today opt for a screen protector proves that there is a need for Corning to further improve the durability of their product. Incorporating a film into the Gorilla Glass manufacturing process has the possibility to greatly increase the durability of the glass. Researchers at a Russian university and the Royal Institute of Technology in Sweden recently published their research detailing the impact of an aluminum magnesium boride film on Gorilla Glass.
To indicate the specific improvements this coating could bring to Gorilla Glass, these researchers tested the hardness and Young's modulus of standard Gorilla Glass in samples of Gorilla Glass with the BAM coating. The results of this testing are displayed here. Consistently, the glass with the coating exhibited significantly higher Young's modulus and increased hardness. Young's modulus, a measure of stress divided by strain, indicates the elasticity of a material, with higher modulus indicating higher elasticity. High hardness along with high Young's modulus is extremely desirable in a glass for use in a display, with the hardness indicating durability against cracking and the modulus indicating flexibility to avoid cracking upon impact. The consistently higher Young's modulus and hardness as a result of the BAM film demonstrates BAM's ability to improve the quality of Gorilla Glass and eliminate the need for screen protectors. This could bring Gorilla Glass to the next level of performance and increase its market competitiveness.
Here's our analysis suggesting experiments to assist in the adoption of BAM coating into the large-scale Gorilla Glass manufacturing. We thought dimensional analysis would be most useful in developing a model for the coating of the Gorilla Glass with the proposed BAM film. In the paper described previously, the BAM was coated on the glass using magnetron sputtering. Magnetron sputtering involves turning a gas into a plasma and then using an electric field to accelerate the positive ions onto the negatively charged target. Using this process, the researchers developing the BAM coating successfully coated Gorilla Glass with a thin layer of BAM that improved the structural integrity of the glass drastically. We suggest the use of dimensional analysis to bring this process to the manufacturing plant. The main variables involved in this process, we hypothesize, are the thickness of the coating desired, the times spent in the magnetron, the gas pressure within, and the mass of the ions. Within these four variables are three dimensions: mass, length, and time. This yields one dimensionless number according to the Buckingham pi method. This number is defined below. After calculating A, B, and C such that dimensions cancel, it is found that A equals -2, B equals 1, while C equals -1. Plugging these in below yields the Buckingham pi constant. With this dimensionless number, experiments should be run to model the system, which could then be used to scale the process to the industrial level.
Going forward, Corning should consider incorporating the use of such a film or coating to increase the durability of their glass. Even though Gorilla Glass today has already reached a high standard, As the worlds of material science and chemical engineering expand, certainly Gorilla Glass will continue to improve in the years to come.